Good morning. First of all, we are going to handle a topic, subtopic, that is mechanism of generation and conduction of nerve impulse. That is how the nerve impulse is generated and how it is conducted from one part to other part. For that, you shall have to understand what are the ions present in it. And suppose this is the action of a neuron. Now, it is covered by a membrane, just like plasma membrane. Within that, the protoplasm present within the action, that is what we call as exoplasm. So this is exoplasm. And outside it is extracellular fluid. Extracellular fluid. Is it clear to you? Now, you have to understand what are the ions present. Sodium ion, outside, that is in the extracellular fluid, and potassium ion, K plus. Inside, that is within the exoplasm. What are the ions present? Potassium ion, sodium ion, and negatively charged protein. Negatively charged protein. Now, you shall have to understand what is the difference of potential or potential difference, and how does this potential difference created from outside to inside. Actually, so if I rub this part, actually within the exoplasm, more amount of negatively charged ions present due to presence of protein. With respect to that, the amount of potassium ion present is comparatively less. Okay? As a result, there is a development of net negative charge inside the exoplasm. Why outside the exoplasm, that is extracellular fluid, what are the nature of charges? It contains sodium ions maximum and some potassium ion, which gives a net positive charge. Now, one more thing you have to understand, that is the flow of sodium and potassium ion through the plasma membrane into or outside the membrane, that is within the exoplasm or the extracellular fluid. See, there are certain ion channels. These ion channels are present within the membrane. Suppose this is one ion channel, this is another ion channel I am drawing here, another ion channel. Now, these ion channel through which the ions will exchange from outside to inside or from inside to outside. Now, the potassium ion, the channels, through these channels, potassium ion are more coming from outside to inside. So there are more potassium ion inside. Is it clear to you? Then what is more outside? Sodium ion. Why? Because of the membrane is less permeable, allowing very less the sodium ions. Okay? Is it clear to you? Potassium ions are 25% more permeable, whereas sodium ions are 10% permeable in comparison to the potassium ions. Is it? This creates a net negative charge inside. You might ask, why is there this is net negative charge inside? Because few potassium ions are coming inside. So potassium ions are coming inside, they are trying to add a positive charge. But negatively charged proteins are there. Is it clear? Which gives a net negative charge inside the exoplasm, although potassium ions are coming inside. Outside, sodium and potassium ions are there, which develops a net positive charge. Positive charge. Here, net negative charge. Charge. Now, the difference of this charge, positive to negative, is minus 70 millivolt. Is it clear to you? When the nerve fiber is at rest, when the neurons are at rest, this is the condition. Inside there is a net negative charge, outside more positive charge, and this creates a potential difference. Okay? And as you know, due to potential difference, the charge starts flowing. Now, this condition, when there is a net positive charge outside and net negative charge inside, which is nearly 70 millivolt, this state is when the neurons are at rest. Is it clear? So this is also called as resting potential. This is also called as resting potential. Is it clear to you?
Yes.
Otherwise called polarized state. Polarized state. Or the neurons are at a stage of polarization or polarization. Is it clear to you? Now, what happens when there is any stimulus applied in a particular area of neuron or nerve fiber action, then this changes the potential. How? When any stimulus acts on it, it changes the permeability of the ion channel. When the ion channels are more permeable to sodium ions start coming here. At this point, more sodium ions were there earlier. Now sodium ions are coming here. As a result, this area earlier it was having positive charge and this part negative charge. But when the sodium ions are coming here, although potassium ions are also coming, potassium ions are freely moving through this channel. So when the sodium ions are coming here, the ionic status at this point become positive. Okay? Nearby negative because of this point only the ion channels allow the sodium ion to come inside. Is it clear? So due to the influx of sodium ion, here develops a net positive charge. Next to it, it is a negative charge. Now when here develops positive charge, here this point it is negative charge. Is it clear? Because of sodium ion from here enters to this part. So positive charge enters to this part means this part there will be less amount of positive charge. So there will be development of negative charge. Now this part when sodium ion enters means it develops a positive charge. Next to it, next to that point here, suppose this is point A. Suppose this is point A. So at point A, outside now develops a negative charge and inside develops a positive charge. Is it clear? Now, next to point A, suppose point B here. Point B inside, what is the charge? Negative charge. So ions will flow from positive to negative. Is it clear to you? Is it clear to you? So now from here the positive ions are coming here. Is it clear? Positive ions are coming here. And what is the charge here? What is the charge here outside? Earlier it was positive. But next to this it is a negative. So from outside, that is in the extracellular fluid, the ions from positive will move to the negative. Is it clear to you? So as a result, now it will become negative. Now this point it is positive charge. So positive charge coming from here to here, but at C point, this is the B point. Now what about C point? Suppose this is C point, point C. Now point C, inside there is more negative charge and outside there is more positive charge. Okay. Now when the positive charge from point B moves to point A, then it will develop a negative charge. Am I right? Because positive charge has moved. Is that clear?
Yes, sir. Yes, sir.
Earlier more positive charge was there, which has moved from here to this part, leaving behind the negatively charged ions. Now inside B point there is more positive charge. C point, point C, there is inside more negative charge, extracellular fluid more positive charge. So inside from here positive charge will move from B to C and outside positive charge will move from C to B. In that way the transmission or conduction of or flow of charges are taking place. This state we call as depolarized state. Is it clear to you? So first polarized state, otherwise called resting potential. Now it is called action potential. Otherwise called depolarized state or depolarization. Depolarization. Is it very clear to you? In that way, polarization, depolarization, and again it will come back to the state repolarization. The process will continue. This is how the nerve impulse is transmitted. Now, when this will come to the end of a neuron, suppose this is the action of a neuron. This end part action is terminating in the form of few fibers and the nodular structure, what you call synaptic knob. Synaptic knob. Okay. This transmission of impulse can be electrical or can be chemical. Chemical process of transmission is a little slow, whereas electrical process of transmission is rather fast. Now question is how the chemical process of transmission from one neuron to next neuron is passing. You know, if I rub this part, here you have another neuron which is having the dendrite part. Dendron. Okay? This is another neuron. Another neuron. It is the dendron or dendrite. Now, the juncture between the end part of one neuron with the dendron of other neuron, we called it as synapse. What is it called?
Synapse.
There can be little gap between the terminal of action and the dendron. This is what we call as synaptic cleft. Synaptic cleft. Now question is how the nerve impulse which has come to the action terminal will jump to the next neuron. How? This is, see children, the synaptic nerve, if I draw it in an enlarged form, this is the synaptic nerve. This synaptic nerve contains synaptic vesicle. Synaptic vesicle. This synaptic vesicle and the other knob of another neuron. Now, the synaptic vesicle contains a chemical. This chemical is called acetylcholine. What is it? Acetylcholine. Otherwise commonly called neurotransmitter. Yes, what is it called? Neurotransmitter. Neurotransmitter. This acetylcholine containing synaptic vesicle now move to this part. Move to this part. And it fuses with that terminal. So what will be the final shape of this synaptic vesicle? Like this. Final shape like this. And it is releasing the neurotransmitter chemical. It is releasing the neurotransmitter chemical. Now what will happen when this neurotransmitter acetylcholine released by fusion of this synaptic vesicle with the end part of the synaptic nerve membrane? Then the neurotransmitter will release and it will affect on the ion channels present over the membrane of another nerve. These ion channels will open up. As a result, it will pass to this next neuron, and next neuron will be excited, and as the way excitation takes place, there will be depolarization of that neuron. Is it clear to you?
Yes, sir.
So I hope I have given you a very clear idea about the mechanism of transmission of nerve impulse. Is it very clear?
Yes, sir.
Any doubt?
No, sir.
Okay, thank you.